So today we talk about the large sample approximate z-test. And so this test is useful when the distribution is unknown. So remember that when we use t-test, okay, the basic assumption is that we have a normal distribution. However, when we would like to use approximate z-test, right, then it means that the distribution is not normal or is unknown. And we can use this approximate z-test when our sample size is very large. So the test statistic is as following, and this is the same as what we mentioned before. So x bar is the sample mean, the observed sample mean. Mu0 is the number we would like to test, which is known given in the hypothesis, and S is the standard deviation of the sample, and N is the sample size. So everything will remain the same as before for the test. The only difference is that we use approximate z-test when the population is not normal, or we don't know whether it is normal, and the sample size is large. And how do we define a large sample size? Usually when n is greater than 40, it is large sample size. And for example, in order to test whether the mean is 30 or less than 30, right? And we collect a sample of 52 observations. So 52 is greater than 40, and in this example, we are not told whether it is normal or not. So we don't know whether it is now normal or not. So here we use approximate z-test, right? Then since the alternative hypothesis is mu less than 30, then we begin to use this one. Okay, we begin to use this one. This is what we are going to use. And just by plugging in the numbers, then we get a z value 0.73. And z sub 0.05 is equal to 165, so you can get that from calculator. Then we find that the observed value is greater than this value. So that is to say, is greater than, so the H0 cannot be rejected. And let's talk about another situation. So when the population is indeed normal, and we have an unknown sigma square. So this is the time to utilize t distribution. So remember we talked about t interval, right? We talked about t interval in the last lecture. However, here, we talk about t-test statistic, but the idea is very, very similar. So here, x bar, when do we use t-test? We use t-test when the population is normal and we don't have a known sigma square, which is very, very common in practice. And so x bar still is the sample size, and mu0 is the test statistic. S is the sample standard deviation, and N is the sample size. And so here, this is one sample t-test. The test statistic, we call it t. Plug in every number, and this number is t. And just as before, we have those three kinds of alternative hypotheses. So by looking at the three hypotheses, we plug in the numbers, and we plug in the numbers into those three inequalities, and then we reject according to the comparison of this t value and the critical value. So here, so this t is calculated from here. So for example, we are not given the sigma square, right? However, we have the x bar equal to 3.8 814 and a sample variance equal to this, and we only have 5 observations. 5 observations is way less than 40, so we cannot not use approximate test. Right? We cannot use approximate test. So here we choose to use the t-test because we have a normal population. So the t-test statistic is given in the following.